morning everyone. So today we'll discuss about a topic from real analysis or calculus. Both these topic of paper 1, which is the calculus, and from paper 2, which is the real analysis, both have some overlapping topics, and the same question which comes in the paper 1 sometimes they give in the paper 2. So today we have length of the arc. See, these topics are the topics which are left untouched by some of the teachers and students. Okay, they don't give much importance to these topics, but questions comes from these topic. Okay, in fact last year only a question was there from this topic, length of the curve, or surface formed by revolution, or volume formed by the revolution. Okay, so a easier topic I would say, but are left untouched by some of the students, those who don't give much importance to these topics. But I will suggest you all to cover these all topics because these are on the easier side, and if this comes in the question, this gives you an extra edge over other students. Okay, so moving ahead, a very basic easy chapter, nothing to worry. There are some important techniques and concepts which I'll teach you. Other than that, nothing difficult of sort. Okay, so the length of the curve. Okay, suppose, so there's this clear formula you have to understand, that if you have to calculate length of this arc from x equal to a to x equal to b, okay, so the clear cut formula would be ds by dx, where s is the length of the arc, or s is equal to integration a to b under root 1 plus dy by dx to whole square dx. Okay, 1 plus dy by dx ka whole square dx. This is the length of the arc. Okay, and when the coordinates of the y-axis is given, suppose you have to calculate this, the same length, but the y equal to c or y equal to d is given, then the coordinate of the length of the arc would be 1 plus dx by dy ka whole square into dy under root, okay, from c to d, that would be s. Okay, so simple, these two formulas are very easy to remember and easier thing to do. Okay, and these formula, that is very easy to understand that where these formula come from. Okay, we have ds square is equal to dx square plus dy square. So dividing it by any of dx or dy and taking the under root both sides, then we get the value of ds, and integrating it over a specific length or specific coordinates, okay, whether be the x coordinate or the y coordinate, we get the required length of the curve. Okay, so there is simple formula for that. You don't have to remember any of those things, just these two formulas. And another formula is if it is given in the parametric form. Suppose y is given as some function of t and x is given as some function of t, then s is equal to integration t1 to t2 dx upon dt whole square plus dy by dt upon whole square. This is under root into dt, where t1 is of the starting point and t2 is the two parameters of the two coordinate system on that curve or that arc. Okay, so these three formulas are very easy to do. Okay, the first one is 1 plus dy by dx ka whole square. Another one is if dx, the coordinate of x is given, that is from x equal to a to x equal to b, and if the coordinates from corresponding y equal to c and d is given, then we write dx by dy whole square and dy, and if it is given in the parametric form, then we form from t1 to t2, and this is the formula. You will later on in the chapter, I'll teach you about the polar curves. If the coordinates are given in the form of r theta, I'll teach you how to calculate that also, but for now we'll start with this in the Cartesian coordinate system. Okay, so now we have a question here. See, I think that understanding mathematics is much easier when you solve questions. Okay, so it's easy to solve question and then you understand to use those concepts in those questions. Okay, so here it is given, the find the length of one loop of the curve this. Okay, if this type of, see if the simpler curves are given, well known curves are given, then it is an easy thing to do. But if these curves which are difficult to trace on the graph, then there is a problem here. Okay, so seeing the equation of the curve, first of all we try to understand the properties of those curves. Not that you have to curve trace it. Okay, that is another topic where we learn asymptotes and curve tracing. But for now, if you don't know the curve, see it's saying that find the length of the one loop. Okay, that means this curve would make a loop. Okay, now when is the loop possible? Suppose, what is the loop? This is a loop. If a function forms this type of curve, this is a loop. So it is asking about the length of one loop. Okay, so for forming a loop, it must be very much, I would say, logical to see that the curve would cut the x-axis or the y-axis twice, at least twice. If it is forming one loop, see in this case, if I say the curve is forming a loop here, so it must be cutting, if I say that a curve is making a loop, okay, so it must be cutting at least 2 points. It can make another loop also, or it can make 2 loops only. But for one loop, it has to cut at least 2 times. The axis, coordinate axis is 2 times. It could cut y-axis or x-axis. Okay. So first we see that where it is cutting that surface. Okay. In this case, we see that if we put y equal to 0, we get x equal to 0 and x equal to a. So there's surely we don't know the graph of this function, this I would say curve, but I can say that it cut x equal to 0 and it cut x equal to a. So it may form a loop here. Okay. Another property to see is to where you should check that if it is symmetric or not, symmetric about any axis or not. Okay, so if you replace, see checking the symmetry is very easy, not much a bigger job here. Okay, you can see that if you replace y by minus y in the equation, then the equation doesn't changes. That means it is symmetric with respect to x-axis. See, I always remember this, I have a technique that I know the graph of y square equal to 4ax. It is a parabola and it is symmetric to x-axis. And in this case also, if you put y equal to minus y, the equation doesn't change. And similarly, if you put x equal to, replace x by minus x, and if it is doesn't changes, then it is clear that it is symmetric about y-axis. That is, if I take the curve y is equal to x square, or suppose I take the curve y is equal to mod of x. Okay, so if you replace x by minus x, the modulus function won't change the function. Okay, so when we see the graph of this function, we get function like this, y equal to mod x, and we can clearly see that it is symmetric about y-axis. So by seeing this loop, I can say that it is given that 3ay square x minus a whole square. Okay. So what do you know about properties? That it cuts x-axis at x equal to 0 and x equal to a. Okay, so this is the function. I once again say 3ay square x. Okay, so it cuts the x-axis at x equal to 0 and x equal to a. Secondly, we see that it is symmetric with respect to x-axis. Okay, so I don't care about what would be this asymptotes or what would be its feasible reason. That's none of our concern. Or if it is concave upward or concave downward, that none of our concern. We need to calculate the length of the arc. So we clearly know it will form a loop like, at least one loop like this, at x equal to 0 and at x equal to a. Okay, so what would be s here? S would be, as I use the formula, s would be integration 0 to a okay. So if I say this is a o a, so I'll get this length only. If I use this formula, I'll get this length. Okay, since it is symmetric about x-axis, we can use it to multiply it with 2. Okay, so by using this formula, I get the length of the arc of OA, but we need to find the length of the arc of the whole loop. So it will be, so the required length of loop will be s is equal to 2 times under root 0 to a integration dy by dx का whole square, and this is dx. Okay, now what do? We calculate this equation. Okay, we are given that 3ay square. Now it's simple mathematics. 3ay square x minus a का whole square. Okay, so first we calculate dy by dx. Okay, so if I differentiate it with respect to x, we get 2y dy by dx, and differentiating this we get x minus a whole square plus x times 2 into x minus a. Okay, so this would be 6ay dy by dx, and here we get, if I take x minus a as common, we get x minus a plus 2x, or it would be x minus a 3x minus a. Okay, so we have dy by dx as 6ay. Okay, now what we have to do? We have to square it. Six ay whole square. Okay, so now what we do? We have to find 1 plus dy by dx whole square, that is 1 plus x minus a whole square 3x minus a whole square upon 6ay whole square. Okay. Okay, so one thing you should do is you should replace, since you have to integrate with respect to x only, so we should write this function in x only, so that we have the integration easy. Okay, in any way you have to do so, later or sooner you have to do so. So we'll write y in terms of x. Okay, so this would be x minus a whole square 3x minus a whole square, and for this 36 a square, and for y square from here we can write as y square is equal to x minus a upon 3a. Okay, so this would be x minus a whole square upon 3a. Okay, so we get 1 plus this x minus a whole square cancels out, 3x minus a whole square upon 12ax. This 3 cancels 12 times, 1a cancels with a square, x minus a square cancels with this, and we left with 12ax. Okay, so we get 12ax plus 9x square plus a square minus 3 to just 6ax upon 12ax. Okay. So moving ahead, we have 1 plus dy by dx whole square is equal to 9x square plus a square plus 6ax upon 12ax. Now this can be written as 3x plus a whole square upon 12ax. Okay, so now for integration we need to find out the under root of this. So under root 1 plus dy by dx whole square, this is equal to 3x plus a upon, now under root of 12 would be 2 under root 3 2 under root 3ax. Okay, 2 under root 3ax. So now we have to integrate it for s. We have to integrate this with this 0 to a 2 times into 3x plus a 2 under root 3a into under root x. Okay, this 2 cancels and we have 0 to a s is equal to 2 cancels. Now this is 3x plus a upon under root x, and here we get under root 3a, and this is dx. Now simply this could be integrated very easily, that is 1 upon under root 3a, and this can be written as integration 0 to a 3 times x to the power 1 by 2 plus a times x to the power minus 1 by 2 dx. Solving this, we get 1 upon under root 3a. Okay, this 3 cancels. This is 1 by 2 x a to the power 3 by 2. Okay, plus this would be, this 2 will go to the numerator. This will be 2 times a to the power 3 by 2, and now you can easily calculate it. Okay, so it is nothing but just using the formula and calculating easily. The important concept which we learn from this question is you don't need to know how to trace the curve. Without tracing the curve also you can solve the question. All you have to see is where the curve or the, I would say, the function is touching the coordinate axis, so you can get the loop. You can easily calculate. In moving ahead, I'll show you how to calculate the length of the arc with respect to the asymptotes at a specific point, or when you find the area. But for now, you have to by this question we learned that if you have to find the loop, then you have to calculate that where this function is touching the curves axes, that is the x-axis or the y-axis. In this case it is touching the x-axis, in other case in the y-axis. Okay, I'll take another example here which says that find the perimeter of the loop of the curve x square, x equal to t square and y is equal to t minus t cube upon 3. Okay, so the question here is given in the parametric form, that is x is equal to t square and y is equal to t minus. Now we have the formula here, we have the formula that s is equal to from t1 to t2 dx by dt whole square plus dy by dt whole square raised to the power half dt. Okay, now we have this formula so that we can easily calculate, but here the challenge which we are facing here is right now is that what is the limit, what is this t1 and t2, since according to the question it says that find the perimeter of the loop of the curve. Now in this case we don't know where would be the loop, since it is given in the parametric form. Okay, so first we try to write this in the Cartesian coordinate system. At least you could try it in writing it in Cartesian coordinate system. Okay, or you can also calculate it. Okay, suppose if I take y equal to 0, we get at t minus t square t cube upon 3 is equal to 0. If I take t is equal to common, 1 minus t square upon 3 equal to 0. That is at t equal to 0, y is 0, and at, I'll first erase this. Okay, so if I take the case where it is getting 0, so we get y is equal to 0 at t equal to 0 and at t is equal to root 3. Okay, so at t is equal to 0 and at t is equal to root 3, it is 0. Okay, and for what values of x does this form 0, y 0? That is at x equal to 0 and at x equal to 3. Since if we put root 3, we get 3. So we can calculate it by seeing the function only, that the curve is touching the x-axis twice. So if we put y equal to 0, we get at t is equal to 0 and at t equal to root 3. So I can say that t is equal to 0 and t equal to root 3 will be the integrating limit, and we can use that formula. That is one thing sure. Another thing which I can do is, it is again that y is equal to t minus t cube upon 3. What if I square this? This is y square taking t common, so we get t square 1 minus t square upon 3 whole square. Okay, and for t square we can write x, this is x 1 minus x upon 3 whole square. So we see that again the same curve, that this is equal to y square, and it is making a loop at x equal to 0 and at x equal to 3, and also we can see that again this is symmetric with respect to x-axis. Since this is y square, if we replace y or minus y, none of those things again. Now we are pretty much sure that how to do this question. You can use the previous formula also, you don't need to use that formula parametric form, but I always say that if you can write a function in a parametric form, go for the parametric form, because parametric form allows you to do the question normally 90%. Sometimes it makes the question much more difficult, but it makes the thing easier. Okay, despite from with respect to Cartesian coordinate system, I find parametric form to be very easy, because in the Cartesian system you have the two variables or two unknowns, that is the y and the x. But when you convert this into parametric form, you get t or theta. Okay, so So we have to find, first of all, using that formula, we need to find dx by dt. This would be equal to 2t, and dy by dt 1 minus 3t square upon 3, that is 1 minus t square, and dx by dt whole square plus dy by dt whole square would be 4t square plus 1 minus t square. Okay, 4t square, this would be 1 plus 3t square. Okay, so if I have to find the value of s, this will be 2 times, since again this is forming a loop, so I need to, it will be of the form like this, that is x equal to 0 and at x equal to 3. So if I integrate, once we get this integration, so if I want to, since it is symmetric with respect to x axis and we have to find the loop, so we have to multiply it by 2 as in the previous example. Okay, so this would be, what would be the limit of t? This will be 0 to root 3, and under root of okay, so this is dx by dt is equal to 2t, and we get dy by dt as 1 minus 3t square upon 3, that would be 1 minus t square, squaring both sides. Okay, sorry, we haven't squared it here, sorry, calculation mistake. So this would be 4t square plus 1 plus t to the power 4 minus 2t square. This would be 1 plus t square whole square. Okay, so if taking under root, we will get here 1 plus t square dt. Okay, so now it's very easy to integrate. This would be t plus t cube upon 3, 0 root 3, and you can proceed and you will get the answer. Okay, simple normal integration. All you have to learn where it just forms a loop, and if you have learned this, you can be sure that you are getting 15 marks in the examination. Okay, in this simpler topic, practice 15 to 20 questions related to this. Then in the polar form I'll teach you, then the surface and the volume. It will hardly take 3 hours to teach. I'll teach you in 3 hours the whole subject. You will take at least 7 to 8 hours, or I say maximum 10 hours to practice it, and then you are done for it. We are sure you will get, if you study at 12 hours a day, 3 hours from me and 9 hours your practice, you are done this rectification, area, surface, volume, you are done with it. Any day a random question comes in the examination, which comes, since last day there was a question that we had to find the area of this asteroid. Okay, there are question also for this, if I say you, see, okay, so you all try to solve this question, that you have to find, I'll not tell you the graph, okay. Okay, so I want you to solve this question. This is the x to the power 2 by 3 plus y to the power 2 by 3 is equal to a to the power 2 by 3, and you have to find the length of this arc, length of this curve. Okay, it is a closed curve, so you can calculate the length of the curve. Okay, and please try to do using the Cartesian formula and also using the parametric form. Okay, and let me know that which method you find it easier. Okay, so thank you.